All right. So jumping back in, looking at that photo that we left off with. Let me pull that up. Okay, so a reference point in this photo is going to be anything that's not moving. So the ramp, the lake, the trees, the mountain in the background, those are all things that are going to be stationary and not moving relative to the motion of the bike. Now, how do we know the bike is moving? If we know those things are staying still, but this bike appears in different locations when compared to them, we know they are moving. Okay? So measuring the path that's taken. Last time we talked about a couple words. We talked about distance and displacement. Distance is going to measure how far an object moves. It's going to measure the total travel distance, okay? Start to finish, doesn't matter where you end or where you started. It's measuring how far it travels. So it measures the whole trip. Displacement is only going to measure how far it is between the starting point and the ending point, but it will also include direction. Okay, so here the turtle traveled a foot. Oops, sorry about that. Down here, this horse, it ran 2 miles toward the west. Okay, so we have that distance or that length measurement as well as a direction, which is needed for displacement. Now, if the horse ran 2 miles west and then 1 mile east, so it ran back and forth, its displacement would be different from this because remember, displacement has to do with starting and end point. Distance, on the other hand, is going to measure the whole trip. Okay, so on to our new words for today. We have speed. Speed describes how fast an object moves, and speed is going to be a measure of distance traveled divided by time of travel. So distance divided by time gives you speed. Now, there's different kinds of speed. There's average speed, which is going to take your total distance divided by your total time. So this would be like if it takes you, let's say, 10 minutes to get to school and you live 5 miles away, you would use your 5 miles as your distance and your total time as 10 minutes. And you would set that up that way. Instantaneous speed is going to be speed at a precise moment in time. So this is a little different. If you're driving to school or riding on a bus to school, you're probably not going to go the same speed the entire trip. You're going to run into some stop signs. You're going to have some roads that you have to drive slower, some roads you have to drive faster. So instantaneous speed is going to show you the speed at a precise moment in time. So this would be like glancing at your speedometer. Constant speed is when you go an equal distance in an equal amount of time. So constant speed, if we're in a car, I like to think of this as cruise control. I turn on my cruise control and that's my speed. I'm not going to speed up. I'm not going to slow down unless I turn it on or off, unless I bump up the speed or hit the brakes and slow down. Okay. Constant speed is kind of like having your car on cruise control. Okay. Now, the equation we're going to use for solving our speed and velocity problems today is our equation for average speed, which is distance over time, or S equals D over T. What I want you guys to do right now is, what you're going to do right now is you're going to get a blank piece of paper and you're going to follow along in the next video on how to make your equation sheet for this chapter.